Yeah. Good evening, everyone. Welcome to Winter School GDSC NIT Andhra. We are very excited to have our first guest speaker session of Winter School. He's Faizullah Sharief. Welcome, Faiz. Welcome to GDSC NIT Andhra. Thank you for accepting our invitation and taking time out of your busy schedule for this session.
So
Thank you
for
very much.
those for those who are not familiar with our guest speaker Faz, he's an iOS developer currently working at Make My Trip and a public speaker. He's proficient in different programming languages that is Swift, Python, Java, and HTML. Along with that, he's proficient in different frameworks such as Data, Cocoa Touch, and different things like Git and web scraping and many more. For today's session, he will be mainly focusing on Git and GitHub and how it is important in development industry. So now I will like Faz to join and take over the session. Faz, you can take over the session. Thank you.
Thank you, Vivek and Meghna, for the warm welcome. I'm glad to be a part of this event, and I hope everyone who's participating gets to learn at least something from my side. So before we actually jump on to the technical stuff, right? Let's just uh, talk about why do we need GitHub in place, and why are we even speaking about this in session, right? Now, Git and GitHub as of today is one of the mostly used source code versioning platforms in the world. I'm only talking about the software industry, right? If not others. So this is something that every software developer, every IT company, and every you take service companies, product based companies, any startup beat, they use Git as a tool to share and collaborate among their developers. What we will try to do is we will try to understand the basics of what exactly is this technology, what it is built upon, what users it has, what we can do with it, right? What is how is it important to know about such a great technology? How is it useful for us in our day to day lives? We'll hopefully answer all these questions throughout the session, and in the towards the end, if we have time, we can have a question answer as well, if that the technology permits. Yes, so without wasting any time, let me start and jump on to the presentation that I have for today. Allow me to start sharing my screen in just a second. Okay. I hope the slides are audible, also visible, and I am audible.
Yeah, you are audible and
Yeah, you're
slides
audible.
was visible.
Okay, okay, great. Let's go ahead. So let's talk about Git specifically, right? Git and GitHub are sometimes terminologies that are used interchangeably, but they are different. They are not the same. So we'll go through each one of them and see what exactly each one of them means, right? So talking first about Git, Git is kind of a tool which is definitely developed by someone, and one of the greatest things that has made it made it become so popular is that it is free and open source, right? Git, specifically talking about Git is a version control system, what they call. For us, it's just a tool that manages, that kind of helps us to manage a history of all the source code that we write, everything that we if we make a change to a file, how do we track those, how do we manage them, everything, all of these tools are compiled into one system, and this whole tool is called as Git. As you see on the screen, it is mainly used for tracking the history of changes, as different people and team collaborate and make changes to one single code base or one single repository. Now, it also Git also makes it possible to restore to previous versions. For example, as a developer, let's say I push something. I made some change to the repository, to the code base, and it messed up something, right? And then I see that it is not the right thing to do, and I want to revert back to the last stable version of the code. Git allows us to do that exact same thing in a very seamless manner. It's just one command, and you go back in history to the last stable version that you think of. That's pretty much about Git. It's kind of a tool. You can think of Git as a software, as a framework, right? As a library, which gives you a lot of possible options to track all the changes, see what changes, who has made what change. If you're seeing one particular file or one particular project, you can see what are the changes that went into that file before I'm viewing it. What are the changes went into that file yesterday, day before, even a year ago, whenever till the time when we started making our project accessible to Git. Now let's move ahead and see. So we've talked about Git. Now we know that it is a tool. It helps us do this, that, track changes, etc., etc., etc. But then why does GitHub come along with Git? Whenever we speak about Git, we usually speak about Git and GitHub, right? We don't speak them in segregated manner. So they are used interchangeably, but they are different things. Speaking about GitHub specifically, GitHub is just a normal hosting website. It's just any website that you can think of, and it's as I told you, it's one of the largest host of source code in the world. Like most of the companies use GitHub. Now again, GitHub is also free for you to use. It has no caps, but then comes it doesn't come with a lot of privacy. So for enterprises or for software companies, this comes with a price. So what software companies do is they purchase a GitHub enterprise plan, and they host their source code in their space that is provided to them, right? But eventually they use the same website. It's GitHub. You can think of it as hosting hosting an image in an some third party image hosting website, right? This is just that you are not keeping your code locally. You are putting it on the internet so that it is accessible to everyone, right? That access you can manage, who can access it, who can whether only you want to access it, and keep it on the internet so that you can, anywhere you go throughout the world, you have the access to the internet, and you can get your source code there. Now we call a particular project as repository. So what is a repository? Repository is nothing but a folder, right? If for example I have my own project, which is, let's say, a mobile application, and it has its own code. It will have some images that will be used in the mobile application. It will have some assets, maybe some animation gifs, right, which will be used in the code. So all these things will be kept in one single folder. It need not be one folder. It can be nested folder structure as well. But the root folder, where we have the whole code, is called as the repository, right? Repository is just a terminology we use in source code versioning systems to mention, to talk about one particular project, one particular folder that contains all the code related to one specific thing. Now, repositories can be confusing. If I call it a folder, there can be a folder inside a folder, but not repository inside a repository. That does not make
Faiz,
sense.
if I might interrupt you, could you please try like representing your presentation again? Because I think there's some problem with it.
Okay.
Yeah, now it's, I think, working.
Fine, I'll keep it this way. Thanks for letting me know. Please let me know if there are any issues, if my audio goes off and stuff. Yeah. So continuing, we were talking about folders and repositories, right? I cannot call a repository to be an exact folder, because they can be folder inside folders. It can be a nested structure. but repository is just the root folder. We can't have repositories inside repositories. Repository is just one standalone root folder that will have all the code, all the data that we want to host on the internet, on GitHub specifically. That's about GitHub. So we've talked about both Git and GitHub. Now let's try to talk about both of them in general and try to connect them, right? So GitHub basically works on Git. Git is kind of a technology that helps us to do stuff, and GitHub is a online hosting repository that enables us to do all the actions that we do with Git, right? So mostly when we deal with Git and GitHub, Git is something that we use in our local machine, and GitHub is something it's kind of a website where we keep all the code, keep the code that we have written locally, right? You write the code in your local system and you copy it to your remote, and this remote is nothing but GitHub. Now we have talked about GitHub as a storage of your code on the internet, right? Now there are many alternatives to GitHub as well, which definitely work on the same principles, but their UI will be different. They'll have some additional features, and some companies use different hosting services. But end of the day, Git is something that most of them uses, right? For the local machine. Now again, there are alternatives. There are legacy systems for Git as well. So yeah, as we talked about Git is something which is the latest thing, right? Before Git we had SVN, and before that we had a lot of things which had their own disadvantages, and now Git is something that is very, very stable, and Git is something that everyone uses. Again, when it comes to hosting your code, different people use different things. For example, Microsoft has a product called Microsoft Azure DevOps, right? They provide their own GitHub, so it's kind of their own internal website that lets you host your code. And there is one more called Gerrit, and this is from Google. I've heard that even Google projects internally, they don't host code on GitHub, but they do it on Gerrit. So there are alternatives, but GitHub is something, it's very common and it's mostly widely used across the software companies. And if we know GitHub, it's very easy for us to know the other working of the other source code hosting solutions. And again, talking about GitHub, someone everyone uses this for their personal projects. If I want to showcase my personal projects, I use GitHub. Now I'll show you how GitHub looks like on the website. Most of you would have seen it already, but I'll go through the flows. I'll try to make you understand the very basic flow, how you can get started with it and stuff like that. Now, moving to the next slide, we have some very basic Git commands. Now, we will not only talk about the commands here, we'll also go through what they mean in specific, right? So as you see, these are the commands that we will, as a software developer at least, we'll use it in a daily basis. Most of these, all of these are the commands that we'll be mostly using. There are tons of commands to do a lot of other things, but we'll go only through the most common things that we do on a daily basis, right? Which is mostly most important to us. Git init, as you know, is an initializer. So init stands for initializing something. So when you go to any folder, so all these commands, right, these are command line tool commands, that is terminal or bash or shell, whatever you call it, right? You type these on your terminal, and it executes. Now when we talk about git init initializes a new empty Git repository. So what do we mean by a Git repository? I've already talked about this. Git repository is a new project that you create, and this will hold all the data, all the code, everything that is needed for you to make your website run, make your app run if it is an application, whether it can be a script, it can be a scraper, anything, right? So git init is just one, you create a folder on your local machine and you do git init. So what happens is, basically, git takes care of everything for you, and it initializes a brand new repository so that you can start tracking changes on the directory that you execute this command on. Fine. Next we have git clone. So this is the next most important uh, command, I would say, because git clone lets you copy, I would say, copy code that is already present on GitHub, right? Let's take for example, I want to download the code of my company. Let's say I've joined the company newly, and all the make my trip applications code is there in their GitHub. And now what I want to do is, I want to take it, copy it into my local machine so that I can work on it. Git clone is the command that I'll write git clone and the URL of the project. So what git clone does is creates a local copy of the whole code base into my local machine. So once git clone, it's kind of downloading all the source code and keeping it in your downloading the whole repository, right, and keeping it in your local machine. So once it has come to my local machine, I can open the code, I can see what is there, I can run it, I can modify the code, etc., etc. Now, once we have cloned the repository, and we already have the code in our local machine. What does git add do? Now, let's say I've cloned the repository. I have the whole source code of any app, let's say, and I make a change, right? I go ahead, maybe it can be a very big feature, it can be one line change as well. I see that one line of code is not written correctly, maybe I'll go ahead and change it. Now what happens is, I have made that change locally, right? And now it's my responsibility to publish this code to the remote. So whenever I say remote is nothing but the GitHub repository where my code is hosted originally, right? Originally it was hosted in GitHub, and I cloned it. Now I made a change. Now again it becomes my responsibility to push. We call this whole process of sending the local change into the remote GitHub repository as push. So it's my responsibility to push that new code into the remote so that everyone else can also see it, right? Now git push, as you see, it's the last command. It updates the remote repository with any changes made locally, right? Now what are the steps through which we can make the changes and then push, right? We need to there is a step by step approach that we take to make a change and push it to the remote so that everyone else can see it. Now here comes the concept of committing, right? This is not any other commit. Commit is like, just think of it as blocks, right? Blocks of changes. There is one initial commit, and then I do something, I do a change and I push, that becomes a commit. And again someone else does a change and pushes, that becomes a commit. So it's a chain of commits, right? That's why we say you can see the history, who has made changes. A change is nothing, a change turns into a commit. That commit is something that goes to the remote, to the GitHub where our repository or our code is hosted. So commit is something which, it's kind of a, think of it as a box containing some changes. Okay, it's a box containing some changes. Now let's say, let's come back to our example. I have made a small change in my code, and now I want to publish it onto the remote. Now what I'll do is, I'll create this box, the small box, which is called as commit. Basically, I'll create a commit with my change and then I'll push it to remote. So in order for me to make a commit, right, it's a two-step process. Then here comes the usage of git add command, right? As soon as I type something, as soon as I types some code, make a code change, I go to terminal and do git status. You see git status here. What does it say? It says shows the status of changes, untracked, modified, or staged. Right? In our case, I have modified some line of code, and if I do git status in the terminal, I will see the modified lines of code. Right? It will just highlight that okay, these are the lines that you have modified. That's it. It will say this much. Now I know for sure that this is the right thing to do, and I want to create a commit out of these changes. How do I do that? Now this is a two-step process. First step is I add these changes to the staging server. Okay, this is the local changes that I've made. Here is the staging server, and here is the actual commit. Think of it as a two-step process, right? 3 boxes. It's a flow diagram. I'm just giving you an example. So the local changes goes into a staging server, and then for the local changes to go into the staging server, I execute git add. Right? Git add is the command that sends my local changes into a staging server. Now let's talk about staging server a little bit. What is the staging server, and why is it coming as a mediator in between my actual commit and the local change? When you stage some changes, they're still local, right? They're not pushed to any remote repository. They're still local, but it gives the developer an extra confirmation that these are the changes that we want to do. Right? We may have a lot of file changes, like 10-20 file changes, but we might not want to commit or push all of them. Let's say I only want 5 file changes to go. In that case, I'll use the staging server and stage only 5 files. Right? From my local untracked 10 changes that I've made, I'll take only 5 changes and then stage them using git add command. Git add, after git add, you can specify the file name, like git add file 1, git add file 2, git add file 3. This way I'll do it for 5 files. And now 5 files out of 10 are in the staging server. Here you can review the code, right? You can just there's another command called git diff that goes through all of your changes and tells you that, hey, look, this was the line of code, and this is the change that you have made. Okay, that is what it tells us. And I'll do a git diff. I'll review the change only once I'm very sure that okay, these are the changes that I want. Then I'll execute the git commit command. Right? So what will git commit do? Git commit will just permanently create that commit wala box, right, that I talked about, which has all the changes, and it will commit into my local repository. Okay, this is a 2-step process. Now still hold on, because the changes are still not remote. We have just created a box, we have just created a commit, and it's still in our local system. Okay, what we have done is that we are very 100% sure that we want to push this to remote, and hence we created a box. That's where we are at. So coming back to the same process again, just summarizing, we made some we first cloned the repository, took a copy into our local machine, we made a file change. Okay, we made 10 file changes. Okay, 10 files we have modified, and I've added only 5 files to the staging server. We reviewed the changes, and then we committed those 5 files. So whenever we commit, right, we give a message to the commit. For example, let's say there was an taking very basic example, there was I've changed the name of the project. Let's say the project name was something called old name. I've made it new name. So in the commit message, what I'll give is change the project name to new name. So this is the message that I'll give. This git commit command that you see, this takes an argument. Okay, and that argument is a message. I'll show you to you on the GitHub, like what how to do this and all that. But just understand that git commit takes a message. So this message, why do we need this message? For anyone who comes after your code change, if tomorrow or a month later someone comes and sees, okay, Faiz has made this change, and he wants to see, okay, this is Faiz's commit, and there is a message. The message states what changes it is in a very descriptive manner. In my case, it will be change the project name to new project. Right? This is the commit message. And okay, now we have committed it, we have given the commit message, the commit box, that commit is created. Now it's our job to push this commit to the remote repository so that everyone else can see it. Everyone on the internet, or everyone who has access to the repository, can see it. For that, we will use the git push command. Right? There is something called git push. This will make sure that all your local commits, whatever is there, goes to the remote. Right? This also, don't worry if you don't understand this, because we'll soon see these as a visual representation of commits in a line, right? So git push is a very basic commit. It'll just push your local changes to the remote repository. And then after I push the change, if someone else comes, let's say someone else comes and tries to clone that repository, this change that I did, even this will go to his copy, because this is the latest change that I've done. Okay, anyone who's copying, who's seeing the code base after my change, he will have my change already. Okay, now that's the use of all these commands. I think I've covered all of the commands here. Git pull. Now git pull is something, let's say there are two persons here in the room, and both the people have taken one copy each of the same repository. This guy also has done git clone, this guy also has done git clone. And then what the guy on the left will do, he will make a line change and then push the code to the remote. Okay, now he has made a line change and push the code to the remote. Now this guy still has the old code that is not changed. Now this guy has to do git pull to take all the latest changes to his local. Right? So one guy makes a change, everyone else has to pull it. Everyone else have to pull the repository so that they see the latest change every day. So on a day-to-day basis, we keep pushing a lot of things. Like we work on teams, right? In any IT company, if you take it, for example, we work in teams, and the whole team will be pushing the code to the remote repository. So every day morning, we will make sure that we have the latest code. We take a pull every morning and then work on the changes that we want. And towards the end of the day, we push all the changes if they are fine. Okay, that was the very brief overview of what these commands mean. Now let me show you how it is to see all these changes on the GitHub itself, right? We won't go to the local terminal command line because we don't have that much of time. So what I'll do is I'll just make sure that I will, we will just see how we can do all of this that we discussed. Push, maybe not push pull, but how do we create a new repository? For example, let's say I've created an application. Let's say it's a game. It's a simple any game that I've created. Now I am, let's say, applying to jobs, or I just want to showcase my code to my friends, right? And let's say it's a website. Okay, website is a better example. So I want to showcase my code to my friends. I want to showcase it to the recruiters because I'm applying to jobs and I want them to look at my code and stuff like that. In this scenario, I would definitely go ahead and upload the code to my GitHub. So as you can see, this is github.com. If you go to github.com, you can also create your own account. You just have to create your account and it will be ready. So this is my personal account. If I go to my repositories, these are the repositories that I have created. These are my personal projects basically, which everyone on the internet can see, right? If you want to access, let's say, my repository, you just have to go to github.com/FAIZY51, and all my code will pop up. You can go through all of see, these are repositories. This is the root folder. This is one project. This, for example, if I go inside, is the photos applications that I created, right? If anyone else, it can be anyone else, I can just go ahead and clone the project, and I can even download the zip and see what code is being written inside here. You can also, go through the UI. If you see, all these are folders, right? These have the dot. So in for iOS app development, we use Swift language, hence it is dot Swift. It can be dot Java, it can be dot Py for Python and stuff like that. So you can, this is basically the source code that I've written for this application. Okay, this is how a nominal repository looks like. Let's go back to repositories. Now let's see how we can create a new repository. Let's say any one of you who don't already have a GitHub account have come here. You'll see this empty, and you'll have an option new here, right? So when you click on new, it says create a new repository, right? What is a repository? It's a folder, it's a project, it's a root folder of a project, where you'll keep, if you have a website, you'll keep index.html inside of it. You'll keep the CSS files, the images, everything inside the root repository. Okay, so I'll give a name, demo app. Okay, let's say I'm creating a demo web app. As I said, demo game or something, anything it can be. I can give a description, it's optional. Anyone who views this, and anyone in the sense is public, right? Public who views your repositories will get a gist. In order for them to get a gist of what it is, we give a description. You'll see where it will be shown in a public profile as well. Okay, this is my description. Now here we have two options. We can make our repository public as well as private. Observe this. You choose who can see and commit to this repository, right? So this is what kind of companies do, because you cannot see make my trip code unless you are inside the company. I cannot see, let's say, Google's code unless it is open source. So unless any code is open source, we keep it private. Otherwise we keep it public. Okay, so for personal projects that you want to showcase, it's not something that is kind of patented code and stuff. So we make it public and leave it like that. Anyone on the internet can see this repository. And next we have readme. I'll just I'll tell you what readme is, and you can just leave it as it is and then create a repository. It's as easy as creating a new folder in your local machine, right? Now this is a quick setup for you to actually start pushing to this repository, right? Now once you have created a repository, you would have already made the web app in your local machine, right? In your laptop or desktop, and then you would want to push that. So all these commands are used to do the same. As I said, if you notice here, we'll just go over only through set of commands. For example, git init, right? Git init is something that will initialize your folder as a Git repository. So in my local system, if I've created a new folder, if I go to that new folder and execute a command git init, that will enable me to push to this repository that I've created. Then you see, you made some file, you created a file readme, and then you adding it to the staging server, right? What you do, you create a file or you modify something, you add it to the staging server. This is where it is happening. This is what it is. Git add readme.m. This will go to the staging server, and then you commit it, right? You create that commit box, and this is what this command is. What it does. I told you that commit takes an argument. This is that argument. Commit argument. I mean, this is called as commit message. That's why -m here. So message is something that describes the changes. For example, I've added a readme. A better message for this would be added a new readme file. In this case, they've given first commit. That also makes sense. Anyway, so once a commit is made, we push it to the remote repository. So I have created my own repository demo app, but now I don't want to. Let's say I want to create something on the repo itself. I'll just go to the demo app repo. Look at this. There are many ways to get started with the repository. You can just start creating a new file here itself. You can upload an existing file to this repository. This is just like a hosting space that you have created. So what I will do for now is create a new file here itself, right? So I'm clicking on this button. It says get started by creating a new file. Okay, this is my new file that I'm creating, and name your file. So this I'll name as something called readme.md. So MD stands for markdown. Okay, don't get confused. You can you can have Python files also, .py, Java files, or PHP files, anything that is possible in the coding world. So here I'll just have a simple div of readme. I'll just say this is readme file. Okay, so I have created my file. I've made some changes, and now what are the processes? Let's go back. These are the file changes. Now if you do it via online, like how I'm doing GitHub, there is no staging server. Why? Because we are already seeing what is in front of us. We don't have to review this. I mean, this is how we review this, right? We go through the file. Okay, I'm sure this is what I want, and then I directly commit. As you see, it says commit new file. So what I'll do, I'll just go ahead and commit it. So as we talked earlier, commit will have a commit message. In this case, it is create readme.md. Look at this. If I want, I can give a custom message also. Readme created, just like this. An optional extended description also is possible. For now, I'll just go ahead and commit new file. Now see that this repository was empty, but now there is one new commit. There is one file in it, which is readme.md, and this is the file that we have created. Right? Let's say I want to modify this file now. I'll show you how to modify as well. You click on this readme file. You click on the edit icon, and this is. I'll say this is a new readme file now. Same thing I'm doing here. If you see, previously it was create readme, now it is update readme, right? So again, I have some options here to create a new branch. We'll speak about branch and see what it is later, but for now we'll just commit the changes. So I've done 2 commits as of now. If I go to the root demo app project, this shows the latest commit, that is updated readme, right? So let's say I've done 2 changes. If you noticed, I want to see I want to track the changes. I want to, let's say, see what was the initial commit. You see here it's updated. This is a new readme file. This is the second change that I made. But what about the first one? So I go to branch. Yeah, you see here it says 2 commits. This particular file has 2 commits. So if I click on commits, this will show me what was the commit, what was the change, when was it made. See, committed 1 minute ago. So I go to I click on, I want to see what was my initial commit, and I click on this readme created. If you see here, it is showing me something, right? It's all green and this is all plus. So just remember this: when it is green and when it is plus, it means that something is added. There was nothing initially, and we added these things. That's why everything is green, and we have a plus sign here. So this is a representation of something is added. Now let's go back and see the updated commit ones. Now we'll see this commit. Here, if you see, there is a red line with a minus sign, and there is a green line with a plus sign. This is an indication that this particular line is removed and this line was added. And Git is intelligent to show you that this was the new addition to the same line, because it highlights that in a dark green manner. Okay, so this is how you can visually create your code, but this is not how it works. This is just one way to do it. what we do is we create locally and push and pull the changes, right? We create, we stage, we commit, and then we push. The steps are the same, the technology that goes behind is the same, but GitHub has given you a way to do it on their UI as well. Let's go back to our slides now. Okay, we have seen how all of these commands kind of work in a UI fashion, right? In the remote, and what we will do now is just go through few concepts that are very important, and just talk about them. So there is one concept called branching when we speak about Git and GitHub. So this is such an important concept. This is because it's very helpful, right? Helpful to collaborate, to make changes, collaboratively make changes. Now, think of branching as, I'll show you in the diagram, visual manner as well. So we talked about commits. Commits come up like this. If you see here, this is one commit, this is the second commit, this is the third commit, and you keep committing, the tree will go on. We call it the commit tree, and this is where the history and all that comes in. You can go to any commit and see what was the change that was done. Now branching is something that allows you to try new ideas, right? Let's say I have a game, and there is no concept of high score in that game, right? The game is hosted in someone's public repository, maybe mine itself. I have created the game initially and I've hosted in my repository, but now I think that I should go ahead and make some changes so that I can add the concept of high score. But what I do not want to do is touch the stable code, right? My stable code should still function very stable. I don't want to mess it up. So what I do is I create, this is a new idea. So new idea, branching allows you to try out new ideas. So in order to try out this new idea, I'll create a new branch out of a main branch. I'll just show you how it looks. This is how it looks, right? So commit 3 was the latest commit that was done on the what was the app that we were talking about, the game, right? And here I wanted to add some additional feature, that is a high score. So I branched out from the commit, right? This is what you see, branching out. So something that is in green is called as a feature branch. This is just, master branch is something that comes to you by default. If you see GitHub where I created, master branch is something that comes by default, right? So you can have multiple branches like this for different features, and this is how companies work, right? Let's say, take example of any company. They do not work on a single feature at a time. They will have multiple people working on multiple features. One might be the high score, another might be some UI enhancement, another might be adding another stage to the game, adding another level to the game. So all of these features will be getting developed in separate branches, right? This is what is called branching. Now, as you can see, I'm not touching the stable code. This is the stable code. Commit 3, commit 4, what you see, this is the stable code. I've just branched out from the stable code and created my own branch, and whatever I do in this branch does not impact the actual main branch, right? So this code is already stable, and anyone who can take a pull will be able to see the latest and the stable code. Okay, now let's talk about how branching helps us in, so we talked about how branching helps us in creating, developing different features parallelly, right? Now, let's speak a little bit more about branching and how it helps us in, let's say, the high score feature that I developed went well. It worked very well, and now I want to make it available to everyone, make it available to the master branch, which is very stable, right? So I'll just make sure that the code is proper, it does not break the existing code, and I'll just test it properly. And then comes the concept of merging, which is called branch merge. Now, merge is something, it's self-explanatory, right? You merge two branches and make one single commit. That is called as a merge. And here it's you see, it's as simple as I've created a new feature, a new high score feature, and I want to add it to the main application. So that's where I merge this code into my main code. Okay, so the merged code will have the latest changes with the high score feature, with all the features that are developed by all the other branches. So as you can see, there can be multiple branches created, one for uh, you know one for feature, one for a hot fix. Just ignore the terminology here. Hot fix is just a name given to a branch. You can give any name, right? As I said, there can be branches that are branching out from a branch, right? I've created a feature branch, and someone sees that, okay, high score, Faiz is developing high score feature, but my colleague thinks that this high score feature can have additional images that would make it, more visually appealing to the gamers. So that is when he'll create another branch from my branch. I mean, another branch from the branch that is already created. So this is how you can keep on going. There is a lot to explore, something that is left to you. That's something about branching. um, I'll go about very simple commands that are used in branching. So if you type git branch, that will just tell you which branch you are on, right? For the repository that we created, if we were to pull the code to clone it and execute this particular command git branch, it will exactly give the same output because it is the master branch. Okay, if you want to see which branch you're on, you can just execute this command. And how do I create a new branch? So if, let's say, I want to create a new branch, I have a new idea, the high score idea, and I want to create it, then what I'll do is I'll just go uh, so I'll just there is a command called git branch hyphen b branch name, right? Git branch is the same command again, but it'll be followed by the name of the new file, name of the new branch. In this case, if you see, it is new underscore feature. Okay, if you say git branch hyphen b new underscore feature, this is the output that you will get. The new branch will be created, but you'll still be in master. So if you want to switch branches, let's say I am now in master, I want to go to my new branch that I've created and then make changes because I don't want to alter the master code. Then I just execute this git checkout new branch, new feature, right? When a git checkout is something that switches you from branch to branch. So if I want, the parameter it takes is the to branch, that is the destination branch they want to switch to. Previously I was in master. You see, there is an asterisk with the green indication. Then after executing git checkout new feature, I am now in the new branch, that is new feature. Now there is another, when we talk about branching, there is comes another thing about merge conflicts, right? Another concept. So merge conflicts is a little bit I would say more of a advanced concept if we talk about introduction, but I'll give you a gist about what it is. And you will notice it when you collaborate with teams, right? You notice it, see it for yourself. So let's say two people are collaborating on the same, two people are changing the same file on the same branch. Okay, this makes a lot of difference. On the same branch, they won't both have just pulled the code and they're making a change on the same line. That is line number 20, let's say. So this guy also is making a change on line 20. This guy also is doing the change on line 20. When both of them push the code, there is a conflict. Git does not know which version to keep, which change to keep, because there are two people who have made a change to the same branch. Let's say um, the initial example that I took, right? I am renaming my project to my new project, but my colleague might rename it to my awesome project. Right? There is a conflict between our ideas, and when we push this code, Git complains about the conflicts, and this is when we have to resolve the conflicts manually, right? So when it comes to resolving conflict, this is how Git will show you on. It'll just append this head and new feature in your code file, in your text file. So if I have pushed apple and my colleague has pushed banana, has made the change, we discuss with him what is the better name, whether apple or banana. In this case, we decide mutually, and then we keep one thing, right? We remove all these unnecessary characters. We'll keep either apple or banana and make the code clean. That's what is called conflicts resolution. It's as the name says. Now that we have talked about features, what you know what Git gives us and everything, we've almost come to the end, and we'll speak a little bit about the uses of Git, right? Where is it used? How is it important to you, all of you, and stuff. So as I said, I've already spoken about this. I think it's used in Git is something that is used in all of the IT companies. There are only very small number of companies that still use legacy versioning systems like SVN and stuff. But Git is something that 90%, I would say, more than 90% of the companies use. So this is also one of the first things people learn in their first software job, I would say, because I have done it, and I've seen it my juniors do it, and this is such an important thing for you students to be, to start your journey as a developer, as a collaborator, as a contributor to any company, any source code, right? And this definitely is a daily task of a software engineer. I myself push my code changes every day to the remote repo, and every software engineer does uses this. There might be a question again. This already you would have gotten you would have got the answer to this question. Why why is it for you? Is even Git helpful for you? How is it useful and stuff? So see, people primarily working with source code use this. One use is definitely the major use is collaboration, right? When different people are pushing code, different people are parallelly working, how do you collaborate to a single code base? You can't have different copies manually. It's a nightmare to just take all the changes, you copy paste. That is a nightmare, and that is what Git was innovated to solve. The collaboration, the parallel changes that different people make to the same code base. And anyone who wants to track the changes, let's say I've created the game, I want to see how the game looked like 1 year ago, right? If you have seen my that the photos app that I showed you, I would go back to that time and see what were the features that I added one by one. I could go back in time and see. And reverting back is also very easy. If I think that photos app that I've pushed a new commit and it's not working fine, let's say high score feature that I developed, I push it and then someone reports an issue. Some other colleague, he takes my code and he says, hey, there is an issue in this. What do? I immediately go back in history to the last commit and then make it the head, make it the latest commit. That's what I do. That's it's as simple as that. If it was manual, you think how bad our life would be. So Git is also for someone who is not afraid of command line tools. Now this is a subjective answer, right? Because these days we have GUIs as well to work with Git. You essentially do not have to know the commands, but it's always good to know the under good to know the core things of a technology is what I feel. It's always I would suggest you learn about, you start with terminal, you start with the Git commands, and then move on to the GUIs that have. You can just on a click of a button you can commit, you can push, you can pull. But Git commands is something that you will enjoy doing as a programmer. It's just something I enjoy doing as well. So that's it I had for today. I think I've covered the most common and basic structure of Git and GitHub, what it is and how different it is. The terminology is Git and GitHub. I hope that you have got at least some insights about what the source code versioning is and how companies across the world use this technology and how it is important to you as well, right? This is what I think. And if you have any questions, I think we have 5 minutes of time. If I'm not sure if there is a question answer section here, but something that I would like to know.
Yeah, Faiz, thank you so much. It is really informative. Now we'll be looking into the queries.
Sure.
Yeah, Faiz. Well, I haven't introduced myself in the previous. I just joined like a bit late here. I am Ritvik, and I'm the lead for GDSC of the NIT Andhra Pradesh chapter. So first off, thank you for actually coming and joining the session, taking this just a day before Christmas. I know there are a lot of festives. It's a festive mood, and learning in the festive mode is quite difficult for many people. But still, there are people who are interested, and thank you for providing it to them. So one question that I do have from my side, and there are some people in my group itself, is that how much of a salary boost or a productivity boost will we be getting if we are going for Git and GitHub, right? So we need to know the exact necessity of Git and GitHub. Like without Git and GitHub, would I be able to survive the corporate world, or do I need anything to go for that?
See, I would say I'd give an honest answer from my experience, right? I've mostly been in initially I've been in support roles as well, but then eventually moved to the development roles where we contribute towards the development of new features. Might it be a simple bug fix, text change as well, right? Something that we definitely need is GitHub. So I would say more than 95% of software roles would need GitHub. Now, if you ask me who wouldn't need it, uh, that is very difficult to answer, even think of, right? Because as far as I've seen, all of the software engineers use GitHub, and that's what people use to collaborate. Unless there is some system where you're not contributing towards one specific code base or one specific system, which is very unlikely, then you don't need GitHub. But mostly for the support roles, when you talk about voice support, where you don't have to code at all, that is somewhere you don't need, because GitHub skills, because you're not contributing to code, right? You might be contributing to marketing, any other roles you take. It can be product development, product thinking, design thinking. It can be decision making or your managerial roles. I would say even people who go to these higher roles, right? They would have done all this GitHub. It's very important for you to understand, because if tomorrow someone comes to you, if you have to collaborate with teams, you have some different teams, and someone comes to you, speaks this terminology, you would have to understand what at least a branch is, right? So I think it's very very important. If you're considering a software career, I would 100% recommend you to know Git and GitHub, because there is nothing apart from this. So it's something that we all use. I hope that answers the question. In terms of career boost, right? See, if a fresher, for example, if some fresher that is joining my team, if he is knowing Git and GitHub already, I would consider that as a bonus point. I would give an additional point in maybe an interview or when he's coming towards the job. That is definitely an added on skill. If you say I know GitHub properly, so that's something that is a very very good skill to have, is what I think.
Yeah. Actually, yeah, that actually pretty much sums up Git and GitHub, because it's been in the rise ever since. I
Yes.
mean, Git was in the rise for a very long time. Then GitHub took over like in 2008, and then from then on, it's been an upward curve. But
Yes.
now we are able to see these new changes, right? Like cloud is taking off, and especially AWS and Azure are being one of the top players. Like I think both of them together they hold around like 50% of entire internet traffic, I guess, around 40 to 50% of it. And there are even other Git alternatives like Subversion, which are being used. Azure uses its own version of thing called DevOps Server, and then there is also AWS's Code Commit. So there are multiple other alternatives to Git to Git, which most of the corporations won't be asking for. Is what I specifically think, because if I'm a person who is trying to apply for Amazon, and Amazon itself is not using AWS Code Commit, then possibly that brings an own question, right? So is the relevance of Git and GitHub reducing nowadays that many options are opening up, or still the threshold for learning it and the market that it used to have before, is it still sustaining out there?
See, there is something called. I mean, we talked about two different things. There is one called there is tooling, right? We have job profiles where people do use tools. For example, SAP and Microsoft Azure. I think things like Create ML, and in Azure you have workflows. I think Dialogflow and Firebase gives a lot of options. These are tools that are developed by companies, and these are built over Git. Hence, you definitely wouldn't require Git skills for managing versions, because that is something that is already done for you, because you're already dealing with a tool, right? Not the source code, not the raw code that you're writing on hand. In that case, even in that case, I would say you will need it. I'll explain why. Um, See, all the tools, right? They are built over Git. For example, we also spoke about Microsoft having something called Azure DevOps. What it is based on? It's based on the same concept that we spoke about. I've personally used Microsoft DevOps, and it's exactly the same thing. We did use Git, but there was no GitHub. Instead of GitHub, there was Microsoft Azure DevOps. And now in my current company, we use Gerrit, something which is open source. So speaking about Git and GitHub, it is a very important skill to still have. Knowing the fact that there are cloud based technologies and stuff, but something that we have to know, the basics never go out of scope, right? When we speak about anything, any memory concept you take, your storage of memory, how it is stored in the computer memory, all these are very very basic fundamental things that will definitely be applicable somewhere in some point in your time, even if you're doing a very high level job like data cleaning and data engineering, and all those hyped up jobs. So I would say Git is something that is very fundamental to software developers, and it will be still relevant. Something might come up which is built on top of it, but the concept will remain the same. I hope that answers your question, Ritvik.
Yes, Faiz. Yes, that actually answers my question. And again, thank you for being present. Just the night before Christmas, and I know many people celebrate it even tonight as well.
Yeah,
So
I
for people who are
actually
watching this,
yeah, no issues. I actually have a travel plan. In an hour I have to pack my bags and go to another city. But anyway, there is no hindrance when it comes to learning and spreading the knowledge. So that's what I like to do, and hence I don't regret
yeah,
that. No
yes,
issues.
the GDSC itself was created with people having the similar mindset that learning comes before anything.
Right.
And we're trying to bring in as many people with the like mindset together. And with
True.
this session, I hope we could have brought at least some people together. So thank you again, Faiz. And I know you're a very busy person, and now you have to go for the other city as well. So we wouldn't want to hold you on for much longer. Okay. So if you there are people from our own team also who are packing for traveling as well right now.
Nice. Good to know. Good to know. Based off your busy schedules, you have taken out time to listen to me. That means a lot to me as well.
Sure. Yes. Thank you for being present in this session, and I hope this will be definitely useful for many people out there. And yeah, so this will also be shared like across platforms. Right now, it's YouTube Live, and then later we'll be sending YouTube links and videos, and even compressing it in a very short format, so it'll be easier for everyone to also go through. And we'll definitely do all those as well. So, thank you for showcasing your presence today, and hope to see you soon.
Thank
Merry
you.
Christmas. Merry Christmas.
Yeah. Merry Christmas to all of you.
Okay then. Thank you everyone for watching this.
Yeah.
And so we'll see you later. We can end the live stream now. Bye.